you want to go write it down, but I think it would be confusing to me, like looking at this chart, because all it is saying, because inverse functions interchange range and domain, yes? Isn't that all that it's doing? So arc sine is the inverse of sine. Duh. Right?
Yeah.
So when I use inverse or arc, I'm finding angles. We know this. The biggest thing is the restriction on the domain. And should be right here. Okay, so remember in trig we had to restrict these domains because they're not one-to-one? Like arc, sine, like sine goes like this. So it's a function, but it's not one-to-one because of that, yes? So restricted it from -1 to 1, and that gives me all the positive and all the negative. Actually restricted it to pi over 2, to negative pi over 2 to pi over 2. So it just talks about the restricting of the domains. That's all this does. So inverse is used to find what? Angles. Okay, so it says note when evaluating inverse trig functions, denote angles in radians. So where is sine -1/2 at? Well, first of all, where is sine 1/2 at?
Oh, I gotta remember this. I know it. I'm trying to think of it. I don't want to say it and then be wrong. Is it the 40? No, that's...
30, 60, 90. Write your 30, 60, 90 down. Your ratios. What's 30, 60, 90? What's your ratios? 1 square root of 3, 2.
Oh.
So what's opposite 1?
This is too much work. This early in the morning is like...
You're making me sad.
I gotta remember, it's been a long time. 2 square root of 3.
No, what angle?
Oh, the angle? 60?
No.
90?
No.
30? 45.
30, 60, 90.
Yes.
1 square root of 3, 2.
That's what I have.
So what's opposite 1? 30.
Okay.
So my reference angle is pi over 6. But I need negative. So sine, we're from negative pi over 2 to pi over 2, right?
Mm-hmm.
So we can go we're like these two quadrants, we can go up and we can go down. So that means theta equals negative pi over 6. Because this stuff doesn't exist. Oh, you guys make me sad.
It'll come back to me.
Okay, so cosine's the first and the second quadrant. Okay, so it's here. So 0 to pi?
Yes.
So where is cosine 0 at?
It's 0 first quadrant. On the...
What angle?
0. Over there.
It's 1. So
Yeah,
it's 0.
I was using my hand to point to it. Okay.
Cosine 0 at pi over 2. Cosine is x.
I gotta remember this stuff. This was a long time ago.
See, I know the cosine and sine, how it's x and y, it's just remember.
Okay. Oh, now I got tangent. Tangent's the same as sine. It goes negative pi over 2 to pi over 2. So tangent is opposite over adjacent. So what angle is opposite square root of 3? 60 or pi over
2.
3. 60 goes in 183 times. Now this one you can use a calculator because we don't know it. Do we?
No.
So how do I put it in my calculator?
Arc sine 0.3.
Arc isn't on your calculator.
Inverse.
Inverse. So what mode do I need to be in?
Inverse mode.
No. Radian.
Radian.
Because it says radian.
Yeah.
So inverse sine
0.3.
is 0.3. And that is approximately 0.3047. Guys, making me sad. Okay, but the whole point is to find the derivative. Okay, don't worry about this. Oh, it's going to switch on me because I touched it. Okay, this just says they undo each other. So arc of 20 or the 2x minus 3, arc tangent of 2x minus 3 equals pi over 4.
So we're just finding.
So if I want to switch these two things, can't I do that? But then I change this from arc to what? What's the inverse of the inverse? Tangent.
Yeah.
So you make it tangent of pi over 4 equals 2x minus 3. Well, what's the tangent of pi over 4?
I need the. Oh, 45, 45, 45. Square root over square root 2 over square root 2.
Which is square root of 2 over the square root of 2, which is what? 1. So 1 equals 2x minus 3.
Well, it's come back.
I'll see if you can do algebra. We'll actually like 7th grade math here.
Oh, we got this.
So add 3, divide by 2. So x equals
2.
2. Guys scared me. Okay, I also could have just taken the tangent of both sides. But what does the tangent and the arc tangent do? Doesn't that just undo itself? Okay. So I have cosine of the arc cosine of 1/2. So I have to solve this first. So where's cosine 1/2 at? I mean sine 1/2 at.
30 degrees.
Or pi over.
Pi over 6.
Okay, so then I do the cosine of pi over 6. It's just a composite function. And what's the cosine of pi over 6?
I really need to pull my sheet out.
Pi over 6 is 30. What's adjacent to 30?
Oh, 60.
No, not the angle, the value. This
Sorry,
is
I'm looking-
opposite. This
I
is
keep-
adjacent.
I keep looking at
Square root of 3 over
the things.
2. Okay, so now we have the arc secant of, okay, so that is something I don't know, so I probably need to make a triangle, yes? And secant is hypotenuse over the adjacent. So square root of 5 over 2 and 2. So how do I find the other one? I find the other side of a triangle.
Pythagorean theorem.
Pythagorean theorem. My geometry kids yesterday. It never goes away. No, it never goes away. Okay, so square root of 5, square root of 5, minus 4 is 1, square root of 1 is 1.
Mm-hmm.
So what's the tangent of that triangle now?
So 1/2.
1/2. So over the first one, we just took the tangent of both sides because it undoes itself, correct? The second one, we did the inside and took that answer and plugged it into the outside function. Just composites, didn't I?
Yeah.
The third one, I didn't know it, so I drew a triangle and then found the tangent of that angle. That was like pulling teeth, guys. Okay, so the whole point of today's the derivative. This table that I'm going to show you is on 376. Let me know when you're good. Okay. This is on 3. Why is it like, it's just like jumping everywhere? Page 376. Can we do the examples and then I'll just let you write?
Yeah.
Can we do that? Okay, so we have arc sine of 2x. So arc sine of u. Right here? Yes?
Yeah.
So what is u?
2x.
And we're going to need a u prime, correct?
Which is 2.
Which is 2. So we just plug it into the equation. So the equation says u prime divided by the square root of 1 minus u squared. So u prime was 2 over 1 minus u squared. So that would be 4x squared. And then the square root. It's really just that basic.
That's all. So it's kind of just plugging it in.
Yeah, just like the other ones. I mean, yeah, you can simplify it sometimes, but... So arc tangent. So arc tangent says u prime over 1 plus u squared. So what's u?
3x.
3x. What's u prime? Is 3. So it is 3 over 1 plus 9x squared.
Yep.
So the derivative of arc sine of the square root of x, well, that would be x to the 1/2, right?
Yeah.
So it'd be 1/2 x to the negative 1/2 for the derivative. Okay, so I plug it into here. So I have 1/2 x to the negative 1/2, which we are definitely not leaving it like that, right? But right now we were writing it like that.
Yes.
Over the square root of 1 minus the square root of x squared. So just x.
X. Yep.
So now we probably need to put this 1 over 2 square root of x times the square root of 1 minus x. Don't yawn. And that looks absolutely ugly, doesn't it?
Yeah.
But is that how it works?
Yep.
Yeah. Ooh, this one would be fun. Okay. arc secant. So we're using this one. That's kind of involved, isn't it?
Yeah.
But we need u and u prime. So what's u?
2x.
2x. Nope. E to the 2x.
Yeah, 2x.
So what's u prime?
2e.
To the 2x? Isn't that 2e to the 2x?
Yeah.
U prime e to the u. Okay, so now I plug that in. So u prime is 2e to the 2x over the absolute value of u. So e to the 2x. Now, is that necessary to have the absolute value on that? Is it ever going to be negative?
No.
No. The square root of e to the 2x squared would be e to the 4x
4.
squared. Trying to write small, and it won't let me write small. So e to the 4x squared minus 1. Oh, we're not done. Can I reduce something?
E to the 2x.
I can reduce the e to the 2x, can't I?
Yeah.
So I get 2 over the square root of e to the 4x squared minus 1. I guess on this one they distribute this because it would be x to the 1/2 times 1.
Are you going crazy?
No, I don't like it. We're not doing it. They do this. They reduce this to 2 the square root of x minus x squared.
They might have multiplied since there's not supposed to be.
Well, they're all in a square root, yes.
Yeah.
Okay? And it's over 1. I mean under 1. So since they're in a square root, it's the square root of x times 1 minus x. This. Now, I would probably write it like this, but then they distributed it. I'm not crazy. Maybe some days, but not today. Or not right this second. Okay, now you guys, I think that's it. Yep, I'll put it back.
Those are on.
Hmm?
I think those ones are on this page.
Yes, those are on your sheet.
The first ones, the first slide, they weren't with the if.
Yeah, because that was just the inverse.
Yeah.
Those aren't derivative rules, but these are.
The rest, they're the.
And they have it to the -1. On here, they're not arc. They have okay, if you're looking at this, it's not arc, it's not to the -1, it's sine h to the -1. No, never mind. They have it. They have it. Never mind.
On like 21.
Yep. 19 through 24. 19 through 24 is what these are.
I don't like that it goes left to right instead of just down. Because I'm looking down expecting it to go in order.
Mm-hmm.
And then it's not.
And we do have one more example if you guys want to do it. I would assume it's more complicated. Good?
Yep.
Let's see what it is. Oh, I mean, we don't have to do this, but if you're going to do the derivative of this, you're going to worry about this, right? And then you're going to do the product rule on this. And then you're going to squish it together what you can. Correct?
Yep.
Because those are...
Do like x times.
Okay, we could just do it. Okay, arc sine of x. There's the u's just x, right? So it's not anything special. So that derivative would be 1 over the square root of 1 minus 1 squared. Oh, it wouldn't be 1, it'd be x. Excuse me, not 1. No, it's u prime, isn't it? Yeah. Okay, so it's 1, and then this would be x squared, correct? So now we got to do the product rule with this. Product chain, actually. So this is x times 1 minus x squared to the 1/2. So the derivative of x is 1. So I have 1 minus x squared to the 1/2 plus derivative of the second. We have first times the derivative of the second, so that would be 1/2 1 minus x squared to the negative 1/2 times negative 2x. So square root of 1 minus x squared plus, well, the 2 reduce, it wouldn't be plus, it'd be minus, wouldn't it? Because of the minus. And the 2's reduce out. So I have x over the square root of 1 minus x squared. And then you have plus 1 over the square root of 1 minus x squared. So I'd have to get common denominators, wouldn't I? Which would be the square root of 1 minus x squared. Okay, so the first one's going to be 1, because it's already over that. The second is over 1, but aren't we, we wouldn't cancel out, but I would get what's inside, right?
Yeah.
So I get plus 1 minus x squared minus x. So so we get I2 times 1 minus x over the square root of 1 minus x squared. Yes? I'm trying to see how they simplified it. Because they took from this step right here, and they said they had 1 minus x over the square root of x, 1 minus x squared, plus the square root of 1 minus x squared. Because these two already have common denominators, yes? Yeah. So they put them together. Oh, this would be squared, wouldn't it? Here, 1 minus x squared. Wouldn't it?
Yeah.
Because I was like, how did they get what they got? So then that would give me negative x squared plus x minus 2. They got down to 2 the square root of 1 minus x squared. So we got to figure out how. Well, to get it out of the denominator, we'd have to multiply by the conjugate, wouldn't we?
Yeah.
If I didn't factor out the negative and left this 2 minus x squared, doesn't that factor to two minus x and 1 plus x? Doesn't it? That doesn't help me. Does this factor to this? Because that'd be 2, and then, it would be minus. I put my minus.
They take the reciprocal
2 plus x.
about 1 to make them all the same denominator.
What?
That 1 minus x squared, like square root of 1 minus x squared, that's over 1. Do they take the reciprocal of it? So then they were all denominators the same.
Yeah, but they don't
Almost
have,
1.
they have it over 1 now. So to get this out of here, I'd have to multiply by itself, wouldn't I?
Yeah.
So if I did it there, I'd have to do it here. But this factors to this factors to this. Well, once I multiply these two together, don't I just get 1 minus x squared? Which would be 1 minus x and 1 plus x, wouldn't it? So this would reduce and this would reduce.
You had me, then you lost me.
Well, we did it right. It's their reducing that I don't like. We've looked at it before. We're like, so they say, let me get rid of all this because we're just seeing what we could do with it, right? They have in the book, they have this step right here. Okay? No, they do not have that step right there. One, they have negative x squared. Let's go back here. Make sure we did this right.
Well, it is a negative 2x before we reduce the 2.
Yeah, but it wasn't squared.
Yeah.
So, like I said, let's go back and make sure we did our product rule right. That's where we would have messed up, right? Okay, so derivative of x is 1, right? And so then we have 1 minus x squared to the 1/2. Then we have x. And then the derivative of this, we have to use the chain rule. So 1/2, 1 minus x squared to the negative 1/2. And the derivative of this stuff inside would be negative 2x. Correct? Okay. Right there. This reduces with this, yes? So I have 1 over the square root of 1 minus x squared plus the square root of 1 minus x squared minus, we forgot this x. Because we have this x and this negative x, so it would be negative x squared over the square root of 1 minus x squared. Correct? So now what they did was they multiplied them all by the square root of 1 minus x squared. Because if I multiply them all by that, it gets rid of it. It gets them out of the denominator. So then I get the square root of 1 minus x squared plus 1 minus x squared, because that would be itself, minus x squared, the square root of 1 minus x squared. All over 1 minus no. Why is this being so hard? It says this reduces to this. How? I'm going to go back a step and go slow. So if I just got common denominators and not multiplied by the conjugate, this is what I would have. Correct? You can't see. I'm put there, that. So how can I combine that? Well, now I have negative 2x squared, don't I? Bless you. Bless you. So now I'd have 1 minus x squared. Wouldn't I? Because I could factor a 2 out. I'd have 2 minus 2x squared over this. Now multiply by the, not the reciprocal, not the conjugate, we're rationalizing. We've spent a lot of time on this problem, but it's good for us to think about problems like this. Because if we do this, we have 1 minus x squared, the square root of 1 minus x squared, all over 1 minus x squared. So what happens to the 1 minus x squareds? They reduce, and I have 2, the square root of 1 minus x squared. But I don't know how they jump from here to here.
I don't know.
I don't know. We got there, yes.
Yeah.
But to go from here straight to there, I think they left out a lot of steps, didn't they?
Yeah. It looks like they did.
Oh, I know what they did. They wrote it like this, like I'm writing it right now. And then they knew that if they multiplied by the radical, that this would reduce, and you'd have both of them. That's Olympic level gymnastics.
That's a question that better not be on homework.
It's gonna. We all know.
Then you'll get it, and you'll look through the answers, and you'll go, okay, I got it to there. And then they started doing obnoxious stuff.
Yeah, weird, crazy stuff.
Okay, so test next Wednesday.
I'm big.
Chillax on Thursday.
Yep.
Okay, Ainsley, you got it?
Have a good weekend.
I think we only do one or two. You want to wait a second and see how many more sections we do, just so you know?
Until like we're done with that.
No. Until we're done with math, no.
Riley got
You're
both done.
silly. Riley.
Look, it's almost been a year.
You're silly.
We only have like 40 days left.
So we only have 5/8 left after this.
And then we're done with that.
No. And 5/8 is integration. So today we're deriving.
Okay.
Monday it's integration.
How much longer do we have? What chapter are we in?
We got till the end of the year, girl.
We got all of April.
56 days.
We got.
Including or excluding? Including weekends.
It's not April. There's 5 weeks. 5 weeks.
How we
56
gonna make that
different
sign up?
diseases.
Yes, please do.
Hey,
56 different
hey.
I get to watch it in 30 minutes. I don't care what Miss Lynn says.
Who are you texting?
Me? What I'm saying.
No, what is Dose doing?
Ew. I'm joking, Dose.
I'm not.
No
I'm
party
jo-
for you.
You think
I'm
a ghost
joking,
scares me,
Dose.
Dose?
I'm joking.
No party for you. They don't get snacks? Mom.
I hate our class.
Dude, it's only because of...
You, Kaden,
Hell no.
man.
No, he hates you guys more than he hates us.
No, he don't.
Yes, he does.
sends you guys out every day.
He doesn't send me stuff.
Yes, he sends one person into your group out in the hallway every single day.
Okay, not associate me with Caden. Either just sit back here and talk to them.
Dose, we gotta settle this. Who do you hate more, the back of the class or the front of the class?
Both?
Which one do you hate more?
I don't know. It depends on the day. I'll take it.
I mean, that's equal then. Equality.
How about you just go with the back left class, side of the class?
Back right, actually.
No, back left, because it's the slice and dice.
That's back right.
You
That'd be
guys
back
have
left.
high excels.
That'd be back
We
left.
know,
It
I'm already
depends
working
which-
on them.
You're just running your mouth. I didn't.
Well, if you're looking towards the north. I'm talking about where Haley sits, that side of the class.
Yeah, that's back right.
Well, it could be-
Yes, that's
You
back.
walk into the
Well,
door,
if you're going
it's
like-
right.
Yeah, we'll just blame them for all our problems.
They do actually hate, I think I hate them the most.
Yeah, that's what I'm saying. For the little they talk is probably the most aggravating.
ever shut the hell.
Oh, I don't talk.
She's always trying to rizz up Noah.
That's what God says.
Okay, you're just lying.
Just leave me alone.
Okay.
I'm trying.
He doesn't want you
I didn't
to.
like you guys.
Good.
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 Smell.
So stop talking to me.
I hate it.
I'm gonna ask Miss Mick if I can work on this. Miss Mick!
I'll say it.
Miss Mick! Miss Mick!
What?
Can I work out in the hall?
No.
Why? Pretty please?
No, I don't think that. I think it's just arguments. Put your opinion on one person.
They scare me.
Exactly.
There's nothing scarier than a female. Right, this man.
What?
Yeah.
I gotta say right to nothing. Nothing.